This is actually going to be 38, 39, and 40. I don't have a lot of room, but I'll just put it there because I didn't have time to run anything off. So this is it. Plus, we didn't do these other two worksheets, so we're going to get that done. But there was something that I was going to say yesterday, but it didn't work for these problems. But it says, if you have, this is on the challenge page, if you have a 5 times 4 times 3 times 2 times 1, it could be written as 5 with an apostrophe mark, and it's read as 5 factorial. Okay. It's read as 5 factorial. So when you see something like this, you just start with that number and you go, okay, 5 times 4 times 3 times 2 times 1. That's it. So how would you write 3 factorial? That's it. I'm going to put it a little above so we have room to work it. 3 times 2 times 1. What's the answer? What's 3 times 2 times 1? The answer, 3 times 2 is 6. All right. Then, what's the factorial for this one? So it's going to be 4 times 3 times 2 times 1. And write it right here so we don't need extra paper. Who thinks they know the answer for this one? 24. 4 times 3 is 12, times 2 is 24. This one's super easy.
It's just 2.
Well, write it out, write the factorial out, and then the answer would be what?
2.
Is 2. Write the factorial out. This is going to be a big one, but there's a strategy to even solve this. So I'll put it right above here. 6 times what?
5.
5 times 4 times 3 times 2. All right. What I'm going to do is I'm going to multiply everything that involves that 5, and that'll give me zeros. So in other words, 6 times 5 is what? 30. 30 times 2 is what? 60. So all I've got to do is 60 times 12. So 60, in fact, I'm going to go like this. 0 times everything is 0. How about 720? 6 times 2 is 12. 6 times 1 is 6 plus 1 more is 720. Or I could have gone 30 times 4 is 120. And then I could have also gone, okay, boys, I could have gone 120 times the leftover 6, 120 times 6. So you could have basically done it either way, but it's 720. And saying that, do we want to do this one? Who knows what's the only difference with this one between this one and this one?
Times 7.
We have to still multiply this times 7 because this would be 7. So I'm going to put it up here. It would be 7 times 6 times 5 times 4 times 2 times 1. So what's the only other number that I need to multiply since I've got this answer?
7.
Times 7. So we can do it. So times 7, it's going to be 0. That is going to be 14. That's 49 and 50. All right. And then I don't want to do that. All right. So now let's go over to what you're going to have to do today. And you may or may not need paper. I don't know yet. I haven't looked at these. But these are permutations. So again, the permutations are the ones that there's an order. And to me, they're actually easier. But some of these are a little unique. So let's go ahead and see. It says, how many locks can the company make without repeating a combination? Sherlock Company makes combination locks with 50 numbers printed on the dial. Okay. Each lock combination is an arrangement, which means, does the order matter?
No. Or yes, sir.
Yes, it does. The order, when you do your combination lock, doesn't the order matter? Yes. So is a combination of 3 different numbers. So I might need paper. Yes, I think I will. So do you have paper? Okay. So on this one, how many different numbers are we going to have? How many? how many numbers on our combination? Each lock is a combination in an arrangement of how many different numbers? 3. So I'm going to put 1, 2, 3. Okay. Then, on this one, if I'm not mistaken, how many choices do I have the first time? Gabriel, I need you to focus. In fact, go ahead and move back one seat. We have 50. Okay. Then if I use the number 20, for example, and he said they're not going to be repeating. If I use the 20, will I have a 20 again? No. How many numbers are going to be left? 49. And then if I use a 12, how many numbers are going to be left? 48. So we just have to work that out. That is not fun. I think that's going to be one of our big numbers. So I think the easiest thing would be to work with the 2 that look really bad, and then we'll multiply it by the 50, because that 50 only has one single significant digit. So let's go ahead and go 49 times 48. That's going to be 32, 39. And then some of you use placeholders. I'm done with the ones place. Now I'm going to start with the 4. Okay. 4 times 9 is 36. 4 times 4 is 16, 17, 18, 19. So right now we have 2, 3, 5, 2, and we've multiplied it with the 49 and 48. What do we still have to multiply by? And I'm going to put 50 like this, because 0 times everything is what? 0. We're done with that 0. So then we're going to pick it up with the 5. 5 times 2 is 10. It's 25, 26. 5 times 3 is 15, 16, 17. 5 times 2 is 10, 11. And why isn't that number there? Oh, it is. Good. After all that work. Okay, so how many locks can the company make without repeating a combination? That's a lot of locks. Wow. They can make a lot. So go ahead and put your answer. 117,600. How many locks? This many locks. Let's try to put some words with our word problems. And that number 11 gets the letter L. And yes, go ahead and fill it out. And I'm going to help you with some of the hard ones. And then you're going to do some of the easier ones. Then. Okay. Got that one down? So the number 10. Okay. How many different 2-letter codes can be formed using 26 letters of the alphabet if the 2 letters must be different? All right. So how many letters are going to be in the code?
2.
2. So that means I need to draw 2 lines. So the TK Plastic Company prints 2-letter code on each of its products. How many 2-letter codes can be formed using 26 letters of the alphabet if the 2 letters must be different? So if I use A through Z, how many letters is A through Z? It's 26. But if my first one is Z, can I use Z again? No. So how many letters am I going to have available? 25. So we're done once we multiply that. So that's the only hard thing today is multiplying. I think these are the hardest, the biggest numbers here. To them is going to be 12. Did anybody get the answer? What'd you get? Okay, and I think that is it. In fact, how many different letters of the alphabet? They can make 650. So how many two-letter codes? 650 codes. And that gets the letter B. That gets the letter. And there's no more 10. And then there's another L that I missed. Oh, there is. Wow. Okay. Alrighty. So let's look at one more. There's a word for first class, second class, major for first. Okay. Righty. Then we'll look at the number 9. And then I'm going to try to have you all do it, because these are basically all the same type of problem. You just need to know how many lines to draw. So it says, if a school offers 9 different subjects, how many different schedules of 5 classes are possible? Who knows how many lines you're going to draw? 5, because you're limited to 5 classes. So 1, 2, 3, 4, 5. Well, on the first one, how many choices of subjects do I have?
9.
9. If I choose history, how many are left? 8. If I choose science, how many are left?
7.
I choose math, how many are left? 6. And then what? 5. So we have to be strategic when we're multiplying this one. I'm going to leave the 6 times 5 last, because that's the easiest. That's going to be 30, and that's basically a single digit with a 0. So let's do the 9 times 8 is what? 72. And 72 times 7, we'll start that right here. 72 times 7, it's going to be. So that's 72 times 7 is that. And we just need to multiply it now by 30. So watch how I'm multiplying by 30. I'm going to stick the 0 out. And what's 0 times anything? So I can just bring it down, and I'm going to start with the rest. So 3 times 4 is 12. 3 times 0 is 0, plus 1 is 1. 3 times 5 is 15. So, oh, wow. Wow. So there's how many different schedules are possible. That's a lot. 15,120 I'll just say schedules. Wow, that's a lot. Is that answer there? And so that gets the letter Y. So where the 9 is, you're going to put the Y. Okay. Then, I'm thinking you can do the rest. Flip it over to the back. Okay. Now, possible outcomes. Simple. Wait until you see. Simple. So, possible outcomes is how many different sandwiches can be ordered. Again, the order doesn't matter. It says when you order a sandwich at Nellie's Deli, you can choose from 4 kinds of bread and 7 kinds of meat. On any sandwich, you can have mayonnaise or mustard or both or neither. Okay, so this looks like, what is mayonnaise and mustard? What do they call those? Condiments. So what we're looking at, okay, I hope I do this one right. I might mess it up on this one. Is I've got bread. So on the S, I've got bread. What else do we have? We have meat, and then we have the condiments. Okay. So how many different types of breads are there?
4.
4 times. So when you are looking for all the possible outcomes, you're just going to multiply all your choices together. So then how many kinds of meat? 7. And on the condiments, we can have what? Mayonnaise, mustard, both, or neither. How many choices is that? 4. And we're going to hope this works. So let's, so 4 times 7 is 28. And 28 times 4 is 32. It's going to be 8, 9, 10, 11. It looks like 112 right here. Woohoo! Okay. How many different sandwiches can be ordered? 112 sandwiches. Okay. And that is right here. And so that answer gets the letter S. Okay. So again, we'll start, usually we'll do the 2 bottom and maybe 1 more here. Maybe we'll do 4, I don't know. So let's look at the bottom. C is combinations. If a baseball team has 5 pitchers and 3 catchers, how many different pitcher-catcher combinations can be made? They don't care the order. I'm not looking like A can be pitcher. It's different. You're just seeing how many possibilities. So what two positions are there? So on the C, it's pitcher and catcher. How many pitchers do we have? 5. How many catchers do we have? 3. And again, this is like 2 people walking together, a pitcher and a catcher. So we just multiply them together. How many combinations? 15. So this is if on permutations I cross off all the ones that are double, because Charlie and Sam would be the same thing as Sam and Charlie. So it's going to be a smaller number. Is there a 15 down there? Yes. So 15 combos. And that is the letter C. Let me see if there's anything that's hard. Oh, I'll do this one, the letter K. And then I decided in a minute for the first name, for the middle name that's going to be easy. Okay. So for this one I think is a little bit different. How many different license plates are possible? In Cornville, bicycle license plates have 2 letters followed by 1 digit. So who knows how many lines we should draw? 3. This is really important today to know how many lines you're going to draw here, because I've got 2 letters and, all right, and 1 digit, 1 number. But does it say that a number, does it say a letter can't be repeated? No, it doesn't say that. So how many letters? So this is a letter, and a number. How many letters are in the alphabet? 26. But does it say that I can't repeat? No, I can have license plate TT5, so that's okay. So how many letters for the second letter? 26 again. And how many single digit numbers are there? Is it 9? So isn't 0 a number? Does it say? It doesn't eliminate 0, so I'm thinking it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you agree? These are all single digit numbers. So what's this going to be right here? It's going to be a 10. And then we'll multiply the 26 times 26. It's 12, 13, 14, 15. there you go, 6,760. Very good. And then, so on that, is that answer down there? Oh, good. Okay, so there are 6,760 different plates. I'll just put different. Okay. Well, no, I'll put different plates. And so that gets the letter K down here. Each shell comes in. And let me see. Okay. I'm going to help you with one more because I really want you to try some yourself. Is this one. According to the map, how many different routes are there from A to D? Look at the picture. Who thinks they know how many lines we should draw?
8.
On W.
4.
Well, people,
1.
A to B is one city.
3.
B to C is 2 cities. Going from C to D is how many cities? 3. So you should draw for W 3 lines. Okay. So now let's look from A to B, B to C, and C to D. Okay. How many routes are there going from A to B? 3. Does everybody see that? I don't look at the whole thing at one time. So just from A to B, there are 1, 2, 3 ways I could go. Going from B to C, how many different roads could you take? 2. Going from C to D, how many different roads could you take? 1, 2, 3. Multiply those together, and you get 18. So there's 18 different ways that we can go. Is that pretty easy? Kind of? Yeah. So I think that's it. Let me see. That 18 gets the letter W. And that's it. So, girls and boys, I'm going to have you all try to finish the rest of them. Permutations, the order matters, and that's the easy multiplying. And this is actually, this one is actually easy also. You figure out how many you have on each event, and then just multiply them. And that's it. You just have to, there's some reading in here, and maybe some underlining, but I know you can do it. If you have any questions, just ask me.